Good morning, Sylvia. Can you hear me and see my screen?
I can see it and
Great.
hear it.
Thank you, Sylvia. I'm going to go ahead and wait a few more minutes to give some people to join up. Do you have any questions for me before we get started or before everyone else gets here?
I'm just doing the best I can at it. I
hear you.
Some of it I can still understand, and some things I'm still like having some trouble with it, but I'm still working on it.
I hear you. Is working with decimals a little bit easier? Are you enjoying that a little bit more?
Pretty much.
I thought maybe so.
Yeah. My geology teacher backed her meeting up until 10 o'clock because it was supposed to start at 9:30.
Oh,
so
no.
I told her I had to leave for 10:25 because I have another class for 10:30.
Well, I appreciate you being here.
So she said, no problem.
Yeah, that's good. I think everyone's trying to be as flexible as they can right now,
Right. So
it's so crazy.
Yeah, I know, and it's about to storm out here.
Yeah, here too. Are you in, is it raining?
Yeah, not yet. I live in Thibodeau.
Are you in Homa?
I live in Thibodeau.
Oh, Thibodeau, it's raining here. I think it's raining. I can't tell. It's been thundering here in Homa.
Yeah, it's all dark and it's thundering, but it didn't get here yet, but it's coming.
I joke because I coach my daughter's softball team normally. Obviously, we're not playing right now, but it's been the most beautiful weather. But if we were trying to play softball, it'd be raining every day, I swear.
Definitely.
It's very strange. Oh, man.
Yeah, I know. I'm tired.
I don't know if you heard, I was in one of the other classes. I can't remember if you were on yet or not, but we're actually moving in a couple of weeks.
Oh, I was here. I was on a computer when you mentioned it, and because someone asked me, who could I recommend as a teacher, and I recommended you. I told her, but the only thing about it, she's not going to be in person. She's going to be online. Said, oh my God.
Oh, I know. I'm actually really sad to leave. This is going to be one of our hardest moves for sure. I appreciate you for thinking of me though as a teacher to recommend.
There's nothing bad I can say about you. I gave her my opinion, about how you take your time and stuff and explain things, and she said, well, I never had a teacher like that. I said, well, guess what? I never did either.
Well, I try. I know it's hard. It's so hard in this environment to teach online in this type of class, but like you said, we're just all doing our best, and I think we're trudging along just fine.
Oh, yeah, pretty good.
I don't know if anyone else. Let me send out a quick message.
Just an early bird.
Wow. I just want to remind everybody that we're doing our class. Oh. There's Sarah. Good morning, Sarah. Okay, why don't we go ahead and get started? And if anyone joins in late, they'll just join in late. So we left off last week in section 5.4. We're going to be talking about decimals still, and we're talking about order of operations, but right now we're dividing. So we left off at this example, 16.1 divided by 3.7. We're going to go through a couple more examples as a refresher before we move on to the next part of this section. So on your own, we're on page 40 of section 5.4. Part B there is 4.1 divided into 81.18. Do either of you remember what we need to do first to even start this problem? And if not, that's okay. what we need to do first is we need to make sure that this number on the outside is a whole number. In order to do that, we have to move the decimal over one place. And remember, to do that, we have to also do it to the number inside. It's the same thing as fractions. Whatever you do to the top, you have to do to the bottom, and vice versa. The same applies here because we're also dividing. So that means our new problem is going to be 41 divided into 811.8. Remember to put your decimal right there so you don't forget. So the first thing we're going to start with is 41 into 81. That only goes one time. So we have 41 down here. When we subtract, that leaves us with 40. We bring down the 1. I think that goes in 9 times. Yep, 9 times. So when we multiply 9 times 41, we get 369. When we subtract that, we get 32. We're going to bring down that 8. Oops. Helps if I do the right stuff, doesn't it? All right, and then we get 8 times. That goes in. And 41 times 8 gives us 328 exactly. So we don't need to go any further. Remember, you need to pay really close attention. In this case, it says to round to the nearest hundredth. So you need to pay very close attention. And remember, if you still had a remainder, that you would have to go all the way out to the thousandths place here to make sure you knew how to round that hundredths place. So pay very close attention to what the problem tells you, where it tells you to round it. But in this case, we know that the answer is 19.8, and you can write 19.80 or just 19.8. That way it tells you that it's rounded to the hundredths place, but it's not necessary. All right, that's how you do it. Remember, the most important first step to remember is to make sure that you have a whole number out here. So if you have a decimal right there, you need to move it over until you have a whole number. So let's look at the next example. Here we've got part C, we've got negative 168.7 divided by 3.51. Oops. All right, here we go. Of course, everything's moving on my screen now. Okay. So we have this. So now we need to write it in long form, but what we need to pay attention to, so we have 3.51. Remember, our answer is going to be negative because there's a negative here, right? 168.7. This needs to be a whole number. So we need to move this over 2 places, which means we need to pull this over 2 places, but we only have 1 number there. So how do we make sure that we've moved that over 2 places? We add in a 0. Okay? So now our new division problem is 351 into, what is that, 16,870. All right, erase that just so we have room to work. Okay, so let's start. 351 is going to go into 1687. Oops, helps if I, 4 times. So we're going to put a 4 here. 351 times 4. Oops, I'm having a problem typing today. 351 times 4 gives us 1404. When we subtract, we get 283. All right, and 351 does not go into 283 like we expected, so we're going to pull that 0 down. That goes in 8 times. So we have 8 times 351 gives us 2808. Subtract, and we get 22. All right, so quick question, are we done? The answer is we're not done because we need to round to the nearest hundredth, and we have a remainder down here. If this was 0 down here, we wouldn't have to keep going, but there's still some number left over that we need to account for. So we need to add a 0 here. I'm running out of room. So we're going to kind of pull it up here. So we have 22. Oops. And this is going to get kind of messy because I'm running out of room. I'm sorry. 22, and we're going to bring down that 0. 351 does not go into 220. Remember, our decimal goes right there, and we need to keep going. So we're going to get another 0. So 351 is going to go in 6 times. 6 times 351 gives us 2106. And subtracting that gives us 94. And we're not done yet. We still need one more place here to tell us if this rounds up or down. So we need to add in another 0 and bring that down, 940. So we have 940 divided by 351 goes in 2 times, okay? Now we're done. We don't care what happens after that. We just needed this place to tell us what to do here. Since this number 2 is less than 5, this stays as a 6. It rounds down. So our answer is 48.06. And that's rounded to the hundredths place. Remember, tenths, hundredths, thousandths, okay? Any questions about the division, guys? Okay. All right, let's go down. So the next thing we're going to talk about is dividing decimals by the power of 10. And remember, we talked about this a little bit ago when we had multiplying. Why does this keep moving over? When we were multiplying by a power of 10. When you're dividing by a power of 10, it's the same idea. We're just moving the decimals a different way. So it's actually kind of a nice little trick. Again, this is a shortcut. And if you don't remember the shortcut, that's okay. You can do the long division out. So the main idea, when dividing decimals by powers of 10, such as 10, 100, 1000, or 0.1, 0.01, 0.001, remember what we said is that when you have 0.01 and whatnot, those are still powers of 10. It has to do with negative exponents. So what you do is, like in this example, we have 44.273 divided by 0.01. What you do is when you're dividing it by a number, a power of 10 that's less than 1, so just these decimals, you're going to move the number of decimal places to the right. So here we have 1, 2 decimal places, so we move to the right 1, 2 decimal places. Again, remember, when you divide by a number that's less than 1, you expect to get a bigger answer than you started with. So here we have 44, oh my gosh, this is driving me nuts. We have 44.273 divided by 0.01. What we end up with here is a bigger number, that 4,427.3, which is what we would expect. And the reason this works is now you're just dividing by 1. And when you divide by 1, that's the same thing as your answer. So over on this side, now we're dividing by 10, which is a power of 10 bigger than 1, right? In other words, a power of 10 that's not a decimal. So here we have 44.273 divided by 10. Now here, when we're dividing by a number that's bigger than 1, we expect to get a smaller number than what we started with. So here we have 44.273 divided by 10. Here we have 1 0. On this side, we're counting zeros, and on decimals, we count decimal places. Here we have 1 0, so we move our decimal place over 1 place to the left, okay? So here we have 4.4273 divided, because we moved it over and it's divided by 1 now, which is the same thing. So we have 4.4273. Again, here we expect to get a smaller number because we're dividing by a number bigger than 1, a power of 10 that's not a decimal. On this side, we have 4,427.3, which is bigger because we divided by a decimal that was smaller than 1. All right? So process. So the divisor, shift the decimal point in the divisor until the divisor equals 1. And that's what they mean right here. You're shifting the decimal place on this side until you end up with 1. So here we moved it over 2 decimal places. Here we moved it to the left 1 decimal place. We just want to make sure that this second part is divided by 1. Dividend, shift the decimal places, decimal point in the dividend the same number of places in the same direction. Then quotient, divide by 1 for the quotient, which is just your same answer. So important notes, always shift the divisor decimal point first until the divisor is 1. To move the decimal point in the dividend the desired number of places, you might need to put in filler or ending zeros at either the front end or the end of the number. In the main ideas example, that number, notice that the number of decimal places moved is equal to either the number of decimal places in the divisor, as in the divisor is equal to 0.01, or the number of zeros in the divisor, as in the divisor is 10. It's just, and those two numbers right here, that 0.01 and 10, those are not the only numbers this applies to. It's just explaining that from the main example above, or main idea above. Try dividing out the examples in the main idea so that the shortcut will make more sense and therefore easier to remember. If you forget the shortcut, you can always use long division. And again, reality check, you can always check this on your calculator, okay? So on your turn, we have two, let me see if I can make this smaller. There we go. So we have 4.653 divided by negative 0.01. So first, right off the bat, is our answer going to be positive or negative? Negative. Very good, Joy, because we have a, well, Sarah, remember, here we have a positive number here and a negative. So whenever, that's okay. Whenever we have a positive divided by a negative or vice versa, remember that whenever they have different signs, then your answer is going to be negative. So we know our answer is going to be negative. Do you guys, now we know it's going to be negative. Do you guys think it's going to be bigger or smaller than this number? The answer. Remember what we're dividing by. So look at what we're dividing by. Do we expect to get a bigger or smaller answer? Smaller. Does everybody agree with that? So Joy, I think what you missed right before you came in, I mentioned it. Whenever we divide by a number that's smaller than 1, which this is smaller than 1, we actually expect to get a bigger number. The reason for that is because you're trying to find out how many groups of 0.01 are in 4.653. There's a lot of groups of 0.01 and 4.653. So think about that. So we expect to get a negative number, and we expect for it to get bigger than 4.653. All right, so now the process told us that we need to move the decimal place so that the divisor, this number right here, is 1. That means we're moving to the right 2 places. So that means we need to move this to the right 2 places. So now we have 465.3 divided by negative 1. Right? Because we moved them over. Remember, whatever we do here, we have to do here. It's the same thing if we had a fraction bar. Whatever we do to the top, we do to the bottom. So same thing with division. Whatever we do here, we have to do here. All right. I don't know if you guys can hear. I've got the door closed and my cat is meowing outside my door. All right, so now we have a net divided by negative 1. So remember, if we divide by 1, we end up with the same answer, but in this case, it's negative 1, so it's the same thing, but it's just negative. So our answer is negative 465.3. Any questions about any of those steps? Again, this is a shortcut. Any questions, guys? Okay. Let's go ahead and move on to the next. Okay. Can you guys hear him? I'm sorry. Okay. All right. So now we have part B here. We have 746. Oops. 0.5 over 10. And this is what I keep saying. Remember, division and fraction bars are the same thing. So first we're going to write this as, you can, if you can do this without writing it as a, horizontally as a division problem, that's fine. I'm going to write it like that just to keep it in the same format that it showed us in the process, in the example, and the main idea, just to make sure it's really, really clear. So this is the same thing as saying 746.5 divided by 10. So any ideas if this number, if the answer is going to be bigger or smaller than 746.5? Any ideas there? Now, I want to point out, now we're dividing by a number that's bigger than 1. It's not a decimal. Bigger. Now, Joy, this is different. We're now dividing by a number bigger than 1. So in the last example, we expected to get a bigger answer because we were dividing by a decimal. Here we're dividing by a number bigger than 1. So we're looking for how many groups of 10 are in 746.5. So think about that and think, do we expect the answer to be bigger or smaller than 746.5? Smaller. There you go. Very good. So the first step in the process is, to make sure that we're dividing by 1. So basically our decimal is right there, right? So we need to move it over 1 place to the left to make sure we're dividing by 1. So that means we need to move this over to the left. So now we have 74.65 divided by 1. And remember, anytime we divide a number by 1, it's the same number. There we go. So there are 74.65 groups of 10 in 746.5, which is what we expected. We expected to get a smaller number. All right, any questions there, guys? Okay, we're gonna move on. Oh, so I'm sorry, we have a couple more examples really quick. Let's go down here. We have, do you guys see this, how to move the decimals, or is this still kind of a little confusing? Little confusing. Okay, it might be because you missed the first part, Joyce. So that might explain some of it. Let's go through one more example then. Sarah and Sylvia, how are you guys doing with this? You're okay with it? Okay. Let's go through one that's got the decimal point, and then Joy, if you still have a question, we'll go through one more, but I think this might clarify it a little bit. 2, 4. We're going to do part C here, 0.001. Okay, and here's the other thing, Joy, I want to point out. If you are still confused, we can go through one more, but also I want you to go up here on page 40, and it explains it right here also. So that might help to review that section as well. We went over that right before you came in. All right, so let's look at that part C. And here we have 8.24 divided by 0.001. Now we're dividing by a number smaller than 1, a decimal point. Do we think we're going to get an answer bigger or smaller than 8.24? Nobody wants to answer? Okay, we're going to end up getting a bigger number because this number is smaller than 1. We expect the answer to be bigger than that, okay? So the first step is to make sure we're dividing by 1. That means we need to move this decimal place over 1, 2, 3 places. That means we need to move this over 1, 2, we're out of places. So what do we need to do when we're out of places? We need to add in a filling 0. So now we have 8240, right? We started here and we moved over 1, 2, 3 places. All right, now we're dividing by 1, and when you have any number divided by 1, it's just itself. So it's 8240, and that's your answer. Again, we expected to get a bigger number. That means there are 8,240 groups of 0.001 in 8.24, which makes sense. All right. Okay, you're gonna have to forgive the highlighting in this section. I'm very sorry. This thing, the PDF would not let me highlight, and it was acting very strange. So I just did the best I could. But I will definitely go through all of this part. So we're on part D, use the order of operations with decimals. So we have our main idea. So far in this chapter, we have learned how to add, subtract, multiply, and divide decimals. Now we will use the correct order of operations to evaluate the expressions containing decimals. One thing that's really important to remember is how to identify your base with exponents. We have dealt with this with positive and negatives. We have dealt with this with fractions, and now we're looking at it with decimals. So we have, in this example, we have 1.3 squared, where 1.3 is the base. So that means you're doing 1.3 times 1.3. Now in this case, here we have a negative in the front, inside the parentheses. That means that your negative is part of your base. So it's negative 1.3 times negative 1.3. On this one over here, we have negative in the front with no parentheses. That means that your base is only 1.3. And the negative is out front. So that's the same as negative of 1.3 times 1.3. So pay close attention to your bases when we're dealing with exponents. So the process is a reminder for our order of operations. We have grouping symbols, which can be parentheses, brackets, or fraction bars. Number 2 is exponents. Remember to pay close attention to your base, like we just said. Next is multiply, divide, left to right. Number 4 is add and subtract, left to right. Important notes, be sure you are comfortable with the different rules for adding, subtracting, multiplying, dividing numbers. We've already gone through these several times, so you guys should be comfortable with them. If you have questions, though, let me know. An exponent acts on whatever it is closest to. If closest to parentheses, the entire contents of the parentheses is being raised to that exponent. If closest to a number, that number, but not the sign in front of it, is being raised to the exponent. Always identify the base before applying an exponent. A negative base raised to an even exponent always results in a positive answer. A negative base raised to an odd exponent always results in a negative answer. Let's go through some examples. All right, so we're on page 43 under your turn, part A, 36.1 minus 7.8 times 2.1 divided by 0.6. So let's remember we're gonna write up here, grouping symbols, exponents, multiply, divide, oops, add, subtract. All right, so let's start going through. What do we have first? Do we have any grouping symbols? Now remember, if you have parentheses without any operations in them, like you're not adding or subtract, oh, thank you, Sarah, sorry. If you have any parentheses, but there's no operation inside of them, that's not a grouping symbol. This is just notation for multiplication. So we do not have any grouping symbols. Do we have any exponents? No, we do not have any exponents. Do we have any multiplying and dividing? Multiply first. Very good. So we have this multiply, oopsie, gosh darn it. Multiply step here, and then we have a divide step here, but we need to do this one first, right? Now, I would normally multiply it all out like by hand. I am very limited on space. So what I'm gonna do is I'm just gonna write what it is, and I'm gonna use the calculator for time's sake and for space sake. So we're gonna start, I'm just gonna write really quick on a side work right here. We're gonna say side work. So we have negative 7.8 times 2.1. And that gives us negative 16.38. Okay, so now we're gonna bring this all down. So we have 36.1 minus 16.38 divided by 0.6. Can anybody tell me what the next step is? Subtract. What about this right here? Yeah, exactly. Very good, Sarah. Make sure to pay close attention. That's very easy to mess up or to miss going left to right. So we're going to do that next. So that's 16.38 divided by 0.6. All right, so that gives us, so that right there equals 27.3. That's 16.38 divided by 0.6. And it's a subtraction, right? We're still negative. So we carry that down 36.1. Now we subtract. Those 36.1 minus 27.3. And that's going to give us 8.8. And did it say where to round to? Let's double check. It did not say where to round. This one we don't have to round. So you would just write 8.8. All right. Any questions? Is this kind of refreshing after some of the algebra stuff we've dealt with? All right, let's go. Let's go to part B. And I'll remember to move the screen this time, hopefully. Negative 8.7 times negative, all right, 0.4 plus 5.3 minus 1.1 squared divided by 4. So remember, we have grouping symbols, exponents, multiply, divide, add, and subtract. So what do we have to do first? What's our number one? What's our first operation we need to do? Exponent? Is there something before the exponent? What's the first order of operation? Grouping symbols. Very good. We have grouping symbols here. So you're right. We need to do this at exponent, but we need to do what's inside of here first before we can even say what that exponent base is, right? So we need to first, so we're going to write this out. We're going to have, this is staying the same, negative 8.7 times negative 0.4 plus, and then 5.3 minus 1.1 gives us 4.2. So what we're saying then is that this part equaled 4.2 squared divided by 4. Right? Is everybody with me right there? Okay. So next we need to apply the exponent. Here is our exponent, and we have a base of 4.2. There's no negative, there's nothing else we need to worry about. So we're just going to apply that base. So that exponent. So we have negative 8.7 times negative 0.4 plus 4.2 squared is 17.64 divided by 4. All right. Now, what's next? So we've done our grouping symbols, we've done our exponents. What's our next order of operation? Multiply, very good. Now, we can actually do these in the same step, right? Because they don't interfere with one another. Does that make sense? So we have negative 8.7 times negative 0.4 gives us 3.48 plus, and then we have 17.64 divided by 4, and we get 4.41. Well, there's only one thing left to do, so let's go ahead and add those two numbers, 4.41, and we're going to get 7.89. All right. All right, let's look at the next one. Let's look at part A. We have 4.7 times 3 minus 8.3 plus negative 1.3 squared. All right. Remember, we have grouping symbols, exponents, multiply, divide, add, subtract. This one's a lot, or the last one, Joy? Because if you think that one was a lot, we have another one coming that's even more fun. Very good, Sarah. Very good. 3 point. I know, Joy. We'll get there. I promise. So yes, 3 minus 8.3. We do need to do first because that's our grouping symbol, right? So this equals 4.7 times negative 5.3. That equaled that, right? Plus negative 1.3 squared. All right, what's next? Negative 1.3. Very good, Sarah. And what's my base? Negative, no, you're right. Negative 1.3, you're right. That is your base. Perfect. Now, so we have negative number raised to an even power. So that means we're gonna have a negative times a negative. So that means we expect to get a positive answer. So we're gonna rewrite 4.7 times negative 5.3 plus, and what this is, I'm just gonna show you guys to make sure you guys remember, that's negative 1.3 times negative 1.3, because that negative is inside the parenthesis. So negative 1.3 times negative 1.3, or negative 1.3 squared, gives us 1.69. 1.69. It's amazing how I can say one number and write another. All right, now what's next? We have done our grouping symbols, we've done exponents. Now we have to do multiply and divide. Our only multiply is right here. We don't mess with this yet because that's an addition. Very good, Sarah. So 4.7 times negative 5.3 gives us negative 24.91 plus 1.69. So we have negative 24.91 plus 1.69 is our last thing. And that gives us negative 23.22. So there's our answer. Again, nothing has changed from that very first module, or the first time, maybe that was the second module that we learned order of operations. We're just now messing with decimals, which are easier than fractions, right? Because you can always check your answer in a calculator, much easier than with a fraction. Your most important things are going to be to remember grouping symbols, exponents, multiply, divide, add, and subtract. And then with the exponents is to identify your base. So make sure you keep really, pay close attention to those. All right, so let's do our last one. I think you guys will really love this one. We're going to do part C. We have 20.7 times negative 1.3 plus 2.1 squared all over 1.5 squared minus negative 0.85. It's okay, Joy, I promise. We're gonna go step by step. It's not that bad, I promise. All right, so let's remember, the fraction bar is a form of a grouping symbol, right? So that means we need to do this part and this part on their own before we can do anything else. So I'm just gonna write a number 1 there. We're just gonna start with number 1 and just do the top part. So we're gonna do 20.7 times negative 1.3 plus 2.1 squared. So let's think about our order of operations within this little problem. So we have grouping symbols. We don't have any grouping symbols. Number 2 is exponents. We do have an exponent right there. All right, so let's do that first. So we have 20.7, if you can even remotely read that 7 and not think it's a Z, times negative 1.3 plus, and then we're going to do 2.1 squared. Notice that they started putting parentheses around the number, even if you don't have a negative. The reason for that is if they want to make sure it's very clear that that exponent applies to the whole number. So here we have 4.41. So that 2.1 squared is 4.41. Now we have to multiply, right? We finished our exponents, we need to multiply. So we have 20.7 times negative 1.3. Let's do this. That gives us negative 26.91 plus 4.41. So then we take the last part we need to do is do the addition. So we have 26.91 plus 4.41, and that gives us negative 22.5. Okay, so that's the top part. So now we need to do the bottom part. All right, so we know that this is negative 22.5 on the top. So let's do the bottom, or the denominator part of the fraction. Whew, can you guys hear that thunder? I don't know if you guys can hear it over the computer. Oops. I don't know if I've told you guys this in class. I've told you I'm from California originally. We don't actually get thunder and lightning in California. I can maybe count on one, maybe two hands, the number of times it happened in the almost 20 years I lived there. So it's crazy that it happens all the time here. All right, so let's do the bottom. We have 1.5 squared minus negative 0.85. All right, so we don't have any grouping symbols, but we have an exponent. So let's start there. 1.5 squared gives us 2.25. And remember, when we subtract a negative, that's the same thing as adding, okay? So we're gonna add 0.85. All right, so now we have 2.25 plus 0.85. Our last operation is 3.1. All right, so we know this is 3.1. So now that we've done all that work, all that fraction reduces down to is negative 22.5 over 3.1. And remember, that's just division. So we're going to say negative 22.5 divided by 3.1. And that equals negative 7. Did it tell us where to round these? To the nearest hundredth. So what I get on my calculator is I'm going to show you 7.25806. But I need to round to this hundredth. So I need to look to that number that is greater than or equal to 5. So that means when we round it, we get negative 7.26 would be our answer. Oh, joy, it gets a lot louder here too, actually, than this. It's just always strange to me to hear it anyway. Any questions about that problem? I know sometimes it seems overwhelming, but like I said before, all you need to do is just think about your steps. And I'm telling you, write a little to-do list. Write out grouping symbols, exponents, multiply, divide, add, and subtract. And then just treat it like a to-do list and go step by step. And once you get those steps, it's really not that bad. And like I said, we've been seeing this order of operations since the very beginning. So I hope you guys are pretty familiar with it by now. Okay? All right, so that's it for 5.4. And I already posted, I know it is kind of fun. I think it's nice the way it cleans up like that. Let's see here, let me get your practice problems up to show you if it'll open. I already assigned them. I posted them already when I posted the recording on Tuesday, but just as a reminder, let me see here. Here's our practice problems for 5.4. We have 9, 11, 15, 17, 19, 73, 33, 37, 45, 47, 51, 55, and 63. So that's it for module 12. We are going to start talking today about module 13. So module 12 quiz is due Sunday. I will start talking about module 13 today because the more we can get through sooner, the more time we have for the final exam review. So just to give you guys an idea of schedule, the final exam is going to open up on May 7th. Just to give you some idea, that is, what is that? That's 2 weeks from today. That's when the final exam will be open, and then it's due, I believe, the 11th. Just to make sure it's also perfectly clear, there will be no extensions beyond the 11th. And only in the case of very extreme extenuating circumstances. So it's extremely important that all of you get familiar with honor lock, read through the directions, make sure that start the exam earlier in the week. Do not wait till the 11th late at night. You need to start working on it somewhere between the 7th, 8th, or 9th to make sure you don't have any issues with it, okay? So that means on the 5th, that Tuesday before the exam opens up, we will have a final exam review. And then our next week's class on Tuesday and Thursday, the more we get done on module 13 before then, we can start the exam review on that 30th, on the Thursday. Joy, what's the dates? I just said the dates, the 7th and the 5th. Okay, yeah. So the 30th of April, I'm hoping to start the exam review. But again, that depends on how quickly we get through module 13. We're going to do a very similar format to what we did before, where we'll go through like a practice exam that's different from the practice exam in my lab. It's more similar to the exam you'll see when you get started. We lost Kim. Okay, so, but I just want to give you guys a heads up and make sure you guys do read through the directions. I highly recommend going and reading through the honor lock instructions that I've posted, that I will post earlier, just to make sure everyone's got the information that they need. But I just want to give you guys a heads up. So we're going to start talking about, this is module 13. So module 13 actually covers 3 sections. It's 5.5, 5.6, and 5.7. And then that's it for the whole semester. So I'm sure you guys are excited to get to the end. I'm sure. So the one thing we're going to start talking about in section 5.5 is how to write fractions or mixed numbers as decimals, and then how to compare them. So we've gone back and forth about fractions and decimals, and we all understand that they are similar and they can represent one another. So when a fraction has a when a fraction has a denominator that's a whole number power of 10, such as 10, 100, 1,000, etc., we can convert it to a decimal as follows. This is really easy. 3/10, as you read it, as 3/10 is the same thing as 0.3. When you have 4 and 17 thousandths, it's read as 4 and 17 thousandths, that's 4.017. So again, the number of zeros we have down here is the number of decimal places you have over here. This only applies when the denominator is a power of 10. When it's not a power of 10, you have to do the division out. So I just want to make sure that part's really clear. This only works when the denominator is a power of 10. A more general process for converting a fraction to a decimal, regardless of the denominator value, is to divide the numerator by the denominator. And this is what I was just saying. So here in this example, we have 1/4. That's the same thing as 1 divided by 4. So you actually have to do out the division to convert that to a decimal. So when you do out the long division, that's what you get. All right, so process. On the left here is when the denominator is a whole number power of 10. Keep any whole number part and write it to the left of the decimal point. Write the numerator to the right of the decimal point, making sure it ends at the decimal place indicated by the denominator. Remember, the number of zeros is the decimal place that it's indicated. So if you have a denominator of 1,000, you should have 3 decimal places after the decimal point. When the denominator is not a whole number power of 10, keep any whole number part and write it to the left of the decimal point, and then divide the numerator by the denominator and place the result to the right of the decimal point. And then I think it'll be a little easier once you see some examples. So don't stress out if that doesn't make 100% sense yet. So important notes: insert filler zeros as needed to make the decimal part end at the correct place value. So in this example from the main idea, 17 over 1,000, there's a zero, that filler zero right there to make sure that the 17 ends where it needs to. There are 2 ways to handle improper fractions. One example is to convert to a mixed number, then a decimal. The reason that might be easier is if you convert it to a whole number, or to a mixed number, excuse me, you know that that's your whole number part. But to me personally, you're adding in a step, because you have to do the division to even convert from here to here, and then you have to do division again if that number's not if the denominator is not a whole number power of 10. I personally, when you have a mixed number or an improper fraction, to me it's easier just to do the division. So I'll talk to you a little bit about that when we go through the examples. Some fractions can be rewritten as equivalent fractions with denominators of 10, 100, 1,000, etc., and then converted to decimals. So in this example, I look at 1/4 and I go, oh, I know 4 goes into 100 evenly, so I can say 4 times 25 is 100. So then I do 1 times 25 is 25, and then that's easier to write just 0.25. That is if it's easier for you. Another example might be right here where we have 7 and 3/500. You don't mess with the 7 at all, but you notice that if I multiply 500 by 2, I get 1,000. So then I just have to multiply 3 by 2 to get 6. So then I know I can convert it that way. So it really is whatever is easiest for you. That's going to be something you're going to have to figure out as you go through the practice problems. Some fractions convert to non-terminating decimals that repeat, just as a reminder. Like for example, 2/3 is 2 divided by 3. When you do out the division, you get 0.66666, and it goes on forever. So you could write that as 0.6 with a bar over it. So down on page 49, we have convert the fractions to decimals. So here we have, let's see if we can just kind of, we have 21 over 100. Remember what we said, when we have a power of 10, we don't have to do any division. Can anybody tell me how many decimal places or maybe what number this is in the decimal? And if you don't know, that's okay. 2. You should have 2 decimal places. Why? Close, Sarah. We're dividing by 100. So we should have a smaller number, like a decimal. Remember, when the numerator is smaller than the denominator, that means that the number is going to only be a decimal place. It should not be bigger than 1. So Joy, you were right. We should have 2, this drives me nuts, 2 decimal places. So that means that we're going to point, and we need to write our number, 0.21, and we have 2 decimal places. Does that make sense? Now, just talking about it, let's say that we had 21 over 1,000. We would need to write 21, but then we need to have 3 decimal places, and so we need to put in a filler 0. Okay, that's just that's not the thing, that's just an example. Let's look at part B. And again, if you don't remember this, you can just do the division and then you'll get there from there. 61 over 10. Now, one thing I want to point out, the numerator is bigger than the denominator. So is this going to have a whole number part for when we convert it to decimals? No. So you're saying that this is less than 1. So in this one, our numerator was smaller than the denominator and we had no whole number part because it was less than 1. Here, our numerator is now bigger than our denominator. So we would expect to have a different result than we had here. So do you still say that we will have no whole number part? Or do you think we will have a whole number part? Okay, that's all right. So how many decimal places should we have after the decimal point? We should have 1 because we have 1 0. So that gives us 6.1. Remember, this number is bigger than 1 because the numerator is bigger than the denominator. When the numerator is bigger than the denominator, we expect to have a whole number part over here in the answer. In this one, our numerator was smaller than the denominator. So that means that we expected not to have a whole number part because it's smaller than 1. Does that make sense now? Yeah, okay, so let's say we had 61 over 1,000. How would I do that? Is that gonna have a whole number part? No, very good, because the top is smaller than the bottom. So we would write 61 and we need to have 1, 2, 3 decimal places. So we have 1, 2, 3. Okay, very good, Joy. We had to add a 0. Very good. Now let's look at another number just to make sure it's clear. Let's say we had, 610 divided by 100. Do we expect this to have a whole number part in front of the decimal? Yes, very good, because the top is bigger than the bottom. So we know this number is greater than 1, and if it's greater than 1, it should have a whole number part. So we're going to write 610, and we should have 1, 2 decimal places, 1, 2. So we end up with 6.1 again, right? Okay. Let's look at the next one. Let's look at for when we don't have 10 in our thing. So here we are given 87.1 half, or 87.1 half, 87 and 1 half. So we already know we're gonna have 87 point something, right? Because that's the whole number part. The way to find whatever goes in this part is to divide 2 into 1. Well, I know it's gonna be less than 1 because 1 is smaller than 2. So I already know I'm gonna need to write a 1 0 there, right? So we're gonna write our decimal point up there, and 2 goes into 10 5 times evenly. So all we know then that 1 half equals 0.5. So that means that our decimal part up there is 0.5. So 87 and 1 half is the same thing as 87.5. That one's a little easier because we know that 1 half is 0.5, but let's take a look when it's a number like 7/9 that we're not necessarily familiar with. So let's do this. So we have part B, we have 13 and 7/9. So again, we know we're gonna have 13 point something because we have a 13 here. But we need to figure out the decimal part from that 7/9. So we're gonna divide 7 by 9. And again, that 7 is smaller, so we know we need a decimal point. So how many times does 9 go into 70? Is it 7 times? Right, so then we have 63. Does it say how far to round this? Let me double check in the instructions real quick. Nearest hundredth. So we need to find this to the nearest hundredth. Okay. So 70 minus 63 gives us 7. So we need to keep going out, right? Because we need to go to the thousandths place to know how to round it to the hundredths place. So I'm gonna bring that down. Ooh, I'm seeing a pattern. It's gonna go in 7 times 63. We're gonna get 7, bring that down, so, oops, 7 again, right? So this would be one of those things that where it equals 0.7 with a terminating thing, or with a repeating bar. However, we need to round to the nearest hundredth. So if I were to round it, this 0.7 would make that 7 round up to an 8. So to the nearest hundredth is gonna be 0.78. Okay? Does everybody see that? So 13 and 7/9 is equal to 13.78 if we are rounding to the hundredths place. Does everybody see that? Or have any questions about that? Good. All right. Well, let's go down. We'll do a few more, 2 more examples. So we have 97 over 100. So this one is a power of 10, right? So we don't have to divide, but what do we need to do? We need to move the decimal. So what we're gonna go ahead and do is write 97, and then how many decimal places do I need? 2, very good, 0.97. So 97 over 100 equals 0.97. And then let's see, what was part C? We have 7 over 6. So is this gonna have a whole number part to it? Yes, very good, because the numerator is bigger than the denominator, see? So when the numerator is bigger than the denominator, we know we're gonna have a whole number part. So let's go ahead and do the division. So we have 6 into 7. We're gonna go ahead and write it out a couple places just to see how far we need to go out. You know what I'm actually gonna do? I'm gonna do this over here. Give us a little more room. So we have 6 going in, oh gosh. 6 going into 7, and we're gonna write out 3 places just in case we need to go out to the thousandths place, because we're rounding, remember? We're gonna write our decimal right there, right above the decimal in the 7.000. So 6 goes into 7 one time. We're going to subtract and get 1, bring that 0 down. 6 goes into 10 one time. 6 gives us 4. 6 goes into 40 6 times, right? We get 36. Bring that 0 down. 6 goes into 40 again 6 times. Do we care what happens after that? No. We just care about this one. This tells us that that rounds up. So this is equal to 1.17 rounded to the hundredths place. Okay? Any questions about how to convert those fractions to decimals? I want you guys all to remember too, when it says round to the hundredths place, you need to go to the third decimal place, that thousandths place, to know how to round the hundredths place. So don't forget about that. All right. The next thing we're going to talk about is how to compare and order decimals and fractions. So to compare decimals and fractions, we'll first convert the fractions to decimals, then we'll compare all the numbers in decimal format. So in this example, we have 2/5 and 0.5. So what we need to do is convert. So what they did is here they showed you how they converted. They divided 2 by 5 to get 0.4. And you only have to go out the number of decimals as you have on this side. But you should go to one more place to know how to round it, okay? So to compare decimals and fractions, we'll first convert them all. So let's go ahead and do that. Convert all fractions to decimals, compare the decimals. If you compare the decimals by graphing them, remember that the number more to the right on a number line is larger. If you compare the decimals by comparing the same decimal place digits, then at the first decimal place where the digits differ, for positive numbers, the decimal at the larger place is bigger. For negative, the larger means smaller. Again, we'll go through a couple of examples to make sure that's clear. When dividing to create decimals, be sure to find the decimals enough places to make a comparison. Converting to decimals is usually the quicker approach. However, you can instead convert to fractions as long as you rewrite all fractions to have common denominator. For example, so they're saying, I don't know, this to me, I'm not sure we want to do this. If you have 2/5 and 0.5, you could actually convert 0.5 to a fraction and then compare. But I think for now, we're going to focus on converting the decimals. All right, let's go down to your turn. We're on page 51. So we have, I'm going to write it and then I'll show you guys the screen. We have 7/8 and 0.88, and we need to know which one's bigger. So let's first convert that 7/8. Are we going to have a whole number part or is it going to be a decimal? We are going to have a whole number part? Is the numerator bigger than the denominator? No. So if the numerator is smaller than the denominator, you're not going to have a whole number part. All right. And this is how we do it. Remember, we write out our zeros. We write our decimal. 8 does not go into 7, and that's how you know that also. How many times does 8 go into 70? It's 8 times. That gives us 64. We get 6, bring the 0 down. 8 goes into 67 times. So that gives us 56. This is 4, bring down the 0. 8 goes into 40 times. How many times? 4 times, 5 times. So that rounds that up to 8.8. See how that rounded that up? So we end up with 0.88 is equal to 0.88. Or 7/8. I wonder if it wants us to go out that far. Hold on. Because that's actually not accurate. Hold on. Let me do this first. Let's do this. All right, we're going to say 0.87. We're going to just say 0.87. Does it have the answer in your guys' book by any chance? On some of these on your turn, it has the answers. Does it have an answer in there? Because I think they actually don't want us. That's right. Okay, I'm sorry. Forget what I said. What we're going to do is say 0.875, or let's just do 0.87. It does not. Of course it doesn't. Let me double check how 0 is added to the hundredths place. Because if we're rounding, they end up being equal. Let me this one I'm going to put on hold. I'm going to write a note and I'm going to get back to you guys on that one because I can't remember how my lab, let's say page, what is this, page 51? I can't remember how my lab needs the answer. I know how I would personally like it, but I want to make sure to confirm to you guys how my lab needs it. Hold on. Give me just 1 second. Yeah, let me double check that. Page 51, your turn. 3, part A. Okay, I'm going to double check that one and I will let you guys know today how you need to handle that for rounding. So I want to make sure I'm giving you guys the right information. Okay, so let's go to part B. And we have -3 2/7 and -3.3. All right. So in this one, let's go ahead and let's convert that. So we know that this is equal to -3 point something, right? So let's go ahead and divide 2 into 7, or excuse me, 7 into 2, 0.000. Well, I guess we only need 2 zeros. Okay. So 7 goes into 20 how many times? 2 times, right? So we're going to say 7 goes into 22 times. That gives us 14. I think that's all we need to do is go to that 0.2 spot because we don't care about rounding because it means it's less than. Okay, so we're going to go ahead and say that that is equal to 0.2. So that's -3.2 and -3.3. So can you guys tell me which one is bigger and which one is smaller? Remember, we're looking at negatives. Very good, Sarah. Because these are negatives, the -3.2 is bigger. Very good. Joy, I can see why you think that, but remember when we look at our number line, if this is 0 and we have 1, 2, 3, and 4, -3.2 would be about there, and -3.3 would be there. And remember, we want to get the one that's farthest to the right on the number line. Right, Sarah, closer to 0 on the negative side is bigger. Does that make sense, Joy? Yeah, okay, good. Yeah, the negative, you always got to remember, it kind of flips it. All right, so let's look at part C. Here we have 5.400 and 27/5. So we already know, because 27 is pretty big compared to 5, that we're going to get a whole number part. So let's go ahead and do out our division. 27, here we do need to go to 3 places. So we have 27.123. So 5 goes into 27 5 times. We get 25. Bring down that 0, it goes out 4 times. That goes into 20. Oops, evenly, right? So if we bring down our 0, we're still going to get 4.00. So what we end up with here is 5.400 equals 5.400. You guys see that? Because this is our 27/5 equaled 5.400. Oh, can't see. Shoot. Sorry, guys. Okay. Gosh darn it. All right, let me do this. All right, so we need to go out 3 places, right? So we know that we're going to have a whole number part. So we have 5 divided into 27.000, right? So we draw our decimal point. 5 goes into 25 5 times. 5, we get 2. Bring down the 0, and it goes in 4 times. And we have no remainder. So we know that 27/5 also equals 5.400. Oops, 00. Which means that these two are equal. Does that make sense? Is that better now that you can actually see it? All right. Let's look at another one. Okay. So let's go down. Let's see another example. This one, we're going to talk about how to order numbers. So we have part A is 5/2, 2.25, and, oops, 2.25, and 2 1/3. Just looking at this, I can already tell you the order actually, because we know that 1/3 is about 0.3 and 5/2 is going to be about 2.5. But let's go ahead and convert them. It's good practice, and we can kind of see what's going on. All right, so we have for 5/2, let's look at here. We need to divide 5 by 2. And we need to go to 2 decimal places, right? So we have 2 goes into 5 2 times. Gives us 4. We have 1, bring that down. We have a 0. 5 with 0 remainder, right? That gives us 10, and that gives us 0. So we know that 5/2 is equal to 2.5. So we can say that. And then here we know that we have 2 1/3 is going to equal 2 point something, right? So we need to divide 1 by 3. And we need to go 2 decimal places. So we know 3 doesn't go into 1, but 3 goes into 10 3 times. We're going to get 1 left over, 0. And we're going to go to 3 again, right? And we're going to get 9. And we don't need to go any farther. We just need those 2 decimal places. So we know that 2 1/3 equals 2.33. Okay. So now we know that this is the smallest, this is the second, and this is the third, right? For going from smallest to biggest. So the way we would rewrite it, though, is we need to write it in the original numbers. So we would say 2.25, then this is next, 2 1/3, and then 5/2 is last. Does that make sense? Anybody have any questions? Okay, good. All right, let's go and do, I think we have time for another ordering one. We've done a lot of the conversion ones. Let's go ahead and, let's look at part B. I want to look at this one really quick on your own. This one, you guys we don't even have to do any math, right? We have -0.5 and 1/2. Can you guys tell me which one is bigger without doing anything? They're the same? What about this right here? One's negative. Yep, exactly. So you don't even have to do any math. You already know that this one is smaller because it's negative and this one's positive. Exactly. All right. That's why I wanted to point that one out, to pay very close attention to your negatives. All right. And then let's look at this part D. We have 7 7/9, 7.6 with a bar. That means it's continuing, right? And then 7 33/50. So we have to do kind of a lot of conversion. So let's start with 7 7/9. So we know we're going to have 7 point something, right? So let's do 9 dividing into 7. And let's go out. Does it say how far to go out on this one? Let's go ahead and go out to the hundredths place. I guess it doesn't even tell you, and you're not given that. That's kind of bad instructions. Let's see how far out we can go. All right, let's go at 3 places. So we have 9 does not go into 7. 9 goes into 70 7 times. It's a 63. I think we've already seen this one. 7 times. Right? And then it keeps going, right? We have 63, gives us 70 7 times. So we know that this is also repeating, it's 7.7 repeating. So we already know it's bigger than that 7.6 repeating, right? So let's look at our last one, our last fraction. We have 7 and 33 over 50. So let's look at 33, oops, let's make this a little lower, or over here actually. 50, and we have 33.00. We'll see how far out we have to go. So 50 goes into 33 0 times, right? Let's see how many times it goes into 330. We have 6 times. So 6 times 50 is 300, right? That makes sense. So we have 300. I have sense a pattern here. So here we have 30 left over. Let's bring down our 0. 50 goes into 306 times. And that gives us that gives us 300 exactly. So we end up with 0.66. Now, this is where I want you to see something very important. We have 0.660. So this equals 7.660. It would be very easy to say that 7.6 repeating is the same as 7.66, but remember that that 7.6 with a bar equals 7.6666. It keeps going. So when we start comparing, we know that this one's obviously the biggest, right? Because it's got a 7 there. But here we compare, 7s are the same, 6s are the same, 6s are the same, but that 0 is less than that 6. So that means that this is less than this. So that means our smallest is here, our second is here, and our last is here. So if we write those in order of the original fractions or numbers, we have 7 and 33 over 50. We have 7.6 repeating, and then we have 7 and 7/9. Does that make sense to you guys? Is all that okay? Good. Oh, good. All right. So that's it, I believe. Let me double check. That's it for section 5.5. So here's our exercise or our practice problems for that. We have number 7, 13, 19, 23, 29, and 39. And really quick, I just want to go back to that one that I was not remembering with my lab, but now I do remember. What it wants you to do is just go to that place. You don't have to go past it and round. You just know that this is 0.880. So what you would do, let me go ahead and do that one really quick, just to make sure it's really clear. I don't want anyone to be confused by that. So for A, I'm just gonna write it and then I'll show you guys, because now I remember how we did this for my lab. I just wanna make sure it's clear. Remember that this is the same thing as 0.880, right? So when we have 7/8, what we do is we divide. So we have 8 going into 7.000. So we would say 8 goes into, or 8 goes into 70. 7 is at 8 times. 8 times gives us 64. We end up with 6, bring down that 0, and it goes in 7 times. Then we end up with 56. It gives us a 4. We bring down that 0. It goes in 6 times. So then we know that 7/8 equals 0.56. Oh, gosh darn it, guys. Is equal to 0.876. So when we compare that to 0.880, these are the same, but this is different. This one's bigger. So that means that this number is bigger than that one. Okay? All right. So if you have any questions about that or anything else, let me know. Just a reminder, the practice problems are going to be for 5.5 or 7, 13, 19, 23, 29, and 39. All right. That's for your module, starting module 13. If you have any questions about module 12 or that one, let me know, or any of the other ones, let me know. But make sure you finish up your module 12 quiz this weekend. We will hopefully finish up the module 13 material on Tuesday, and that means that we can start the final review on Thursday. Even if we have to wrap up module 13 on Thursday, that's okay. So if you guys have any questions, let me know. I'm here through email I'll be checking it all weekend. All right. You guys have a great weekend. Thank you for coming to class today.